Good morning, students. We continue with page number 4. We discuss with multiple charges. That means more than 2 charges are there. What will be the effect? We reach up to here. We have 2 charges. Let us say Q1 and Q2. Any order I keep, distance between the 2 is R. We know there will be forces. In this case, repulsion. Force of repulsion between the two. The forces are equal and opposite. If this is 10 Newton, this has to be 10 Newton. They are equal and opposite. We have seen last time. Now, this force, let me say, I have illustrated that last time. It is the force acting on the first charge, F1, because of the second one. See, it's a F12. It is a vector. Similarly, the force acting on second charge, we write F2. Due to the first one, I write F21. We have seen last time the forces are equal and opposite. Now, let me consider another charge, let us say another charge Q3. Q3 may be positive or negative, let us say positive, placed nearby. Now, I am having 3 charges, I say multiple charges. We want to discuss what is the effect. So, the question is, let us see the situation. 2 charges are placed at a distance R. Force acting on one of them, each one of them is going to be this. If I keep another charge nearby, this force will be changing or not. Repeat, force between 2 charges, does it depend on presence of other charges nearby? It is observed, no. Force between these 2 charges, if it is 10 Newton, it is not affected by presence of other charge. Reason, using the formula, the Q1, Q2 charges are the same, distance is same, so the force has to be same. So one concept, the force between 2 charges does not depend on the presence of other charges nearby. Second point, what is the total force acting on Q1 because of Q2 and Q3? There will be force between Q1 and Q2, we have already seen. Similarly, force between Q3 and Q1. If both are positive, as illustrated, let me join Q3 and Q1. Yes, the force will be repulsive. This will be a repulsive force. Force acting on Q1 because of Q3, which notation we will use? Most of us will follow. Force acting on the first charge, F1, because of the third charge, F13. Any notation is okay, but here we are used to this one, F13. It is a vector. So, the total force acting on Q1 because of Q2 and Q3 is going to be one addition of F12 and F13. We studied 11th standard parallelogram law of vector addition. What does it say? If 2 adjacent sides of a parallelogram are represented by the 2 vectors, then the diagonal is giving us the vector addition. What does it mean? With these are the sides, I complete a parallelogram. I draw parallel to the F13. I draw parallel to F12. I am getting a parallelogram. I show the diagonal. This is going to be the diagonal. It is going to be the resultant. So I write, this is going to be the resultant. So conclusion, if there are 3 charges, system of 3 charges, what is going to be the force, total force acting on a charge due to the other charges? I will define the force between the first one and second one, F12, force between first one and the third one, F13, and then make the vector addition. When I put it in a sentence, that idea we are writing in page number 4, we get that the title is forces between multiple charges. So, multiple charges, what is the argument? Point 1, the force between 2 charges does not depend on presence of other charges. Point number 2, the total force acting on a charge due to a number of other charges is vector sum of vector addition of the individual forces. Force between 1 and 2 I find separately, force between 1 and 3 I find separately, then this is the force 1 separately, this is the force 2, find the vector addition of 1 and 2, that is going to be the resultant. That idea we require while doing the problems. We have not started the problem, that time it will be clear. Then somebody will ask, what will be the case when there is another charge? Q4. For our discussion, for our syllabus only 3 are enough. 4, it is same thing is continued. Same thing is continued. That idea is the title on page number 4. The title is with the diagram, forces between system of 3 charges. That is only for problems. You don't have to go through the equations there. In the WhatsApp message, when we start that portion, I will be informing you. So you don't bother about that. So now we go to page number 6, that is electric field. What about the intermediate mathematical parts? Not required. In the higher studies, we come across. So multiple charge idea is over. I repeat, force between 2 charges does not depend on presence of other charges. Then, the second part, the force due to a system of charges is the vector sum of individual forces. That idea we got. Now we go to page number 5, electric field. We want to introduce a concept called electric field. To understand that, everybody knows, let us say I have taken a small bar magnet. It is a bar magnet. Surrounding the magnet, I say there is a magnetic influence. Near the magnet, influence will be more. Away from the magnet, influence will be less. How we know? Everybody knows. Suppose I take a magnetic material, maybe an iron, maybe some iron piece, something, or maybe in this case, the small pin, I bring it closer, it is attracted. Why it is attracted? Because a bar magnet is having some magnetic influence. Near the magnet, it will be stronger. Away from the magnet, it will be weaker. So magnetic field is present, we say surrounding the magnet. Near the magnet, field is more. Away from the magnet, field is less. Similarly, there will be what is called electric field. Electric field we represent by letter E. Then you will ask, what is electric field? The idea is, let us say I am having a charge Q. Surrounding the charge, there is an electric influence. How I know there is electric influence? So there are going to be charge here, some charge I kept here, maybe 2 coulomb, 3 coulomb. Surrounding that some electric influence is there. How I know there is electric influence? I must keep another charge nearby. If there is a force between them, I know this is having a charge. So to distinguish the thing, original charge, we just deliberate like capital Q instead of small q. We can use any notation. We use capital Q. It is going to be called a source charge. It means it produces the electric field. It produces the effect, source charge. To see the presence of the charge, presence of the electric field, I must make use of another charge that I call it as test charge. So 2 things are coming. One is going to be source charge, another is going to be test charge. What is test charge? That is just to test the presence of the electric field. I clarify. Everybody knows this is going to be, let us say, is going to be an electric tester. What is the meaning of that? If I want to know whether there is current in a line or not, I will put the tester inside. Example, I will just keep it inside with the holder here. It is inside the plug, and if the light is there, it will be glowing. If the current is not there, it won't be glowing. It is a tester, electric tester. What is the use? To see whether electric field, what we call electric current is there or not. If the current is there, it will glow. Current is not there, it will not glow. Similarly, to know whether there is electric field surrounding a charge, I make use of a test charge. It is going to be 2 properties of test charge. It must be positive, plus it must be very small. I keep a charge plus Q just to distinguish. It must be positive and it must be what we call very small. Why? That we will explain. It must be positive and very small. Find the force acting on the between the two. In this case, there is a force of repulsion. Find the force, then divided by the charge Q, that quantity we call electric field. Conclusion, what do you mean by electric field? It is surrounding a charge, there is an electric influence or electric field. How to measure it? Keep another charge, that is going to be test charge. What are the properties of test charge? It must be small and it will be plus, it must be positive. Why these conditions? We will explain in the just after a small break. Now E is F upon Q. We introduce the next equation. We will continue after a break. Thanks.